So I am going to show you how to prove that figures are special quadrilaterals, and this is going to be able to be found in 5.7 in your books, so you have a point of reference to follow along with. Okay, your objectives are as follows: to prove that a quadrilateral is a rectangle, to prove that a quadrilateral is a kite, to prove that a quadrilateral is a rhombus, to prove that a quadrilateral is a square, and to prove that a quadrilateral is an isosceles trapezoid. I should make mention, don't cry, but this is the last video for the semester. So, you've got all these videos now to study off for the finals, and this is the last section of the semester. So hopefully you've been paying attention all the way up until now, because the final will be on everything up to this point. Alright, but again, let's move right along. Okay, so first, how to prove that a quadrilateral is a rectangle. First, you have to make sure it has been proven or given that the quadrilateral is a parallelogram. And then you can use one of the following methods to prove it is a rectangle. So first would be if the parallelogram contains at least one right angle, then it's a rectangle. And second, if the diagonals of the parallelogram are congruent, then the parallelogram is a rectangle. So either one of those two, once you've shown it's a parallelogram, would work. Also, you could prove that a quadrilateral is a rectangle without first showing that it's a parallelogram if all four angles of the quadrilateral are right angles. Then it's a rectangle. Okay, so that last one you can do without showing first that it's a parallelogram. Alright, now, let's prove that a quadrilateral is a kite. So if two disjoint pairs of consecutive sides, remember consecutive, right after each other, disjoint, separate from each other, are congruent, then it is a kite. So that would be this and this, and that, and that. If you have a quadrilateral and you have the sides like that, these two are congruent, and then the remaining two are congruent, then it's a kite. If one of the diagonals of a quadrilateral is the perpendicular bisector of the other, then the quadrilateral is a kite. So, again, if you had two diagonals, and one would be the perpendicular bisector, so that would mean that this would be the perpendicular bisector of that, and you didn't have the sides, you could still show that it was a kite. Okay, proving that a quadrilateral is a rhombus. Okay, so again, you have to show for a rhombus that it's a parallelogram first, and if the parallelogram contains a pair of consecutive sides that are congruent, then it's a rhombus. So if it's a parallelogram and like that was congruent to that, it would be a rhombus. If either diagonal of a parallelogram bisects two angles of the parallelogram, then it is a rhombus. So that would mean that if you have this as a diagonal and it bisects both and they're congruent, then it's a rhombus. You can also prove that a quadrilateral is a rhombus without first showing its parallelogram by if the diagonals of the quadrilateral are perpendicular bisectors of each other. Okay, so you would have the two diagonals perpendicular, and they bisect each other. Not necessarily saying that they're all congruent, but that from the diagonal it's divided into two equal segments, and then the other diagonal is also divided into two equal segments. So that could show you that it's a rhombus. Okay, proving that a quadrilateral is a square. If a quadrilateral is both a rectangle and a rhombus, then it's a square. Because remember all those properties that the square had, that it shared: rectangle, rhombus, parallelogram, everything. So if you have all that, you can show it's a square. Proving that a trapezoid is isosceles. So if the non-parallel sides of a trapezoid are congruent, then it's isosceles. So notice that you would first say that it's a trapezoid. And if the non-parallel sides were congruent, then it's isosceles. If the lower or upper base angles of a trapezoid are congruent, then it is isosceles. So again, we're going with the fact that you've proven or shown or it's given that you have a trapezoid first. And finally, if the diagonals of a trapezoid are congruent, then it is isosceles. So there's three methods for that one. Alright, so let's see how this would help you in a proof. So you're given that GJMO is a parallelogram, that segment OH is perpendicular to segment GK, so we would say that there, and that MK is an altitude of triangle MKJ. So first we start with our givens. Then we could say that OM is parallel to GK because opposite sides of a parallelogram are congruent. So that's by, or should be parallel. So that's by definition of a parallelogram, basically. We would then say that MK is perpendicular to GK because an altitude of a triangle is perpendicular to the side to which it is drawn. So even though it says it's an altitude, remember, we don't say anything about it being perpendicular, even though that's the definition. So you have to state that first. So that would be a common step that might get skipped. You could then say that OH is parallel to MK because if two coplanar lines are perpendicular to a third line, meaning they're both perpendicular to the same line, then they're parallel. You could then prove that OHKM is a parallelogram because if both pairs of opposite sides of a quadrilateral are parallel, it is a parallelogram. Remember, we said that OM is parallel to line GK, which means everything on this is parallel. Okay, so there are your opposite sides that are parallel. We've shown that, so now we can say it's a parallelogram. We can then say that OHK is a right angle because perpendicular segments form a right angle, and that's the only one we have to prove because remember, if you've shown it's a parallelogram, you only need to show that one of the angles is a right angle. So you don't need to state that MKH is, unless you were doing that in place of OHK. Either way. Then you could say that OHKM is a rectangle because if a parallelogram contains at least one right angle, it is a rectangle. So that's how you would use it in a proof. And again, that wraps up your videos until mid to end of January. So enjoy it, enjoy your break. Go back and watch the other ones again so that you can help kind of prepare for the final. Don't forget to put this stuff on your flashcards either. All right, you guys have a good one. Enjoy the rest of your weekend, and we will see you next week.